Good morning and welcome to a geometry video. Today's topic of thought is area. Now, area fundamentally is just a two-dimensional measure of size, as opposed to, say, length, which is only in one direction. And it's really an extension of humans' obsession with measuring amounts of stuff, right? Every area practical, application question, it seems, always asks about how much stuff can I fit on here? How much water can I fit in the swimming pool? Well, I guess that's more volume, right? How much cheese can I fit on the pizza, right? Which is a very critical, important question because you always want to maximize the amount of cheese on your pizza. So let's get into it. Area being a two-dimensional size, let's bring back a reminder from the days of algebra. The two-dimensional plane, the Cartesian plane, right? We have our x direction and our y direction. Area is a measure of how big, right? It's the size and shape of a particular shape, in both of those directions. And the thing I want to highlight right here, what is the relationship between those two directions? They are perpendicular. That makes a right angle. The other direction, that second dimension, is perpendicular to the first. And that is the critical, fundamental idea behind all area calculations. They must be perpendicular. Two directions perpendicular to each other. Okay? X and Y are perpendicular, which means to find the area, you must multiply two perpendicular measurements. You're going to find the length of one side, the length of another. You want to multiply to get the area, and you got to make sure those two numbers you are multiplying represent perpendicular measurements, or directions, or the sides of object. Might not be the size, the side itself, right? Very frequently you run into this guy, a non-right triangle, where we can clearly call any of these sides a base, but in order to multiply the height, we have to know how far is it perpendicular to, right? Make that right angle. How much is that length? That is your height, not any of the other sides necessarily. Okay. Where do all of these come from? How am I supposed to know what formulas, what? Everything builds off of that idea, right? No matter what shape you have, okay, it will have a particular formula. Some a little bit more complicated than others, but all of them come from the good old rectangle, the most basic of base times height, length times width, however you want to phrase it. You can call each side whatever you like. Just know that you're multiplying two perpendicular measurements. Right? So the rectangle is our starting point because it just is those two perpendiculars multiplied together. It's only from that we branch out to get, say, the triangle, which if you take two triangles together, you get, hey, that looks kind of like a rectangle. It's almost as if the triangle is half the base times the height, right? Or we can just start getting silly with it and say, what happens if we slant the rectangle, right? Make it all crooked-like. Oh, now it's a parallelogram. Same thing applies. Pick any side you like. Let's pick this side just to be contrary. Okay, what distance is perpendicular to that? Well, we got to make sure we draw a perpendicular line that reaches the other side, right? That's our perpendicular height, right? Now, classically, you would probably use this and a perpendicular line there that goes to the opposite side, right? I just want to be different. Let's go perpendicular this way to hit the opposite side, right? That'll be our width, right? You got to fit this shape down the hallway, okay? The hallway's width is going to be measured perpendicular from one wall to the other, okay? That's what you need to know. different problem about rotating the shape in order to actually fit, but you get the idea. Perpendicular, perpendicular, perpendicular. What else we got? You could combine those two shapes together, right? Putting triangles and rectangles together. That's how you get trapezoids, right? You can stick a whole bunch of triangles around a central shared vertex point, and you end up with all kinds of polygons. Okay, that's where you get the derivation for the formula for a polygon. It's just how many sides? Well, that's how many triangles you sliced it into, again, like a pizza. Okay? And we can extrapolate that idea even further to get the circle, right? It all comes from the same idea. You still have to multiply perpendicular values. That's it. There is nothing more to it. Obviously, I could get into the specifics on each of those, but I want this video to be a short kind of overview of the underlying idea. Perpendicular. Multiply perpendicular. And see how does this shape relate back to the basic rectangle. Is it half the rectangle? Is it twice that rectangle? Is it the same rectangle but slanted? Is it a piece of a rectangle plus another rectangle? Right? You get into the complex, multiple conglomerate kind of shapes going there. All of these are perfectly valid. All of these trace backwards if we run the arrows, back the other way, up the page. Right? You get back to rectangle, which is base times height, 2 perpendicular directions. That's all there is to area. And if you can remember that, you can pretty much derive, as necessary, any area formula. Or just write it down in your notes and refer to it later. All right, that's going to do it for now. Thank you so much for watching. So long, farewell, enjoy the rest of your day.